Hi, my name is Łukasz Langa,
And my name is Pablo Galindo.
and this is the Core.py podcast, a new podcast where we want to discuss internals of Cpython and our adventures in making a new version of your favorite programming language. Today we're going to be talking about our sprint in Brno, where we spent 5 days at the Red Hat offices in the Czech Republic to meet with other core developers to work on things that will land next October in Python 3.13.
This is also the time of the year when all the CI for Cpython breaks suddenly. It's a big mystery. We don't know why it happens, but at this time of the year, everything is broken. We have our best engineers working on solving this problem. Hopefully, we can find a cause soon.
So definitely lots of activity. This time, in fact, we had a few unique things happen on the sprint. We had guests from the HPy project discussing C API issues and the possible future for that. And we announced the new deputy Cpython developer in residence, who is going to be Petr Viktorin, up until now a Red Hat employee, but a veteran of the Cpython project.
It was an interesting fact that the sprint said Red Hat and he left Red Hat to be a developer in residence, right?
Well, that was one of the reasons why we didn't announce his role sooner than this. We found that it would be a little too awkward to have the host of sprint be on his official way out already.
Right, it's strategical reasons, people say.
Right. Speaking of which, we don't have a location chosen for the 2024 core sprint yet. We're hearing this should be rotating between the continents. Some of our guests from the United States sent us, excited or frustrated, sometimes it's hard to say, descriptions of how they use public transit in Europe. So they would wish for the next one to happen somewhere in the United States. We don't really have a candidate for a host yet. So if you're thinking right now, oh, that could be me, well, contact us. We definitely want to hear from you.
Right, because for the listeners that are not aware about this is something that we have been doing for a while. I think you organized maybe the first core developer sprint back in the day.
Right, back in the early 2000s, there was a one-time event which was called the Need for Speed, and it was an event I think it happened in Iceland, if I'm not mistaken, and it was very well regarded. People had great memories of it, but that was way before my time. So by the time we started gaining traction with Python 3, that was when we were working on Python 3.6. I organized a sprint at Instagram first, and then the following year at Facebook, which worked on a 3.6 and 3.7 respectively, which started the ball rolling. Then we moved to Microsoft and to Bloomberg, to London.
Right, even more than rolling, right? Like if someone goes to the Cpython repo and looks at those statistics that GitHub shows, you can see like a huge spike of activity. And I'm pretty sure that is one of the 2 sprints that you organize. So
yes. Until the Faster Python team at Microsoft was formed, the Python 3.6 sprint week was the most productive week in the project's history, from the very beginning.
That's where app strings were forged, right? If I recall correctly.
Yeah. There were a few things that happened there, and this was a very well-timed sprint because it was just before the beta 1 release. So we still were working on finalizing features.
Right.
Okay, so every one of us who comes to the sprint obviously wants to see the location. Obviously, we want to see each other as people and get to know what changed since we last saw each other. But the core of why we're there is to actually do some work. So, what would be some of the highlights of the week for you, Pablo?
Well, there is plenty of stuff. Actually, it was a very proactive sprint, I have to say. So for me, I think the highlights were the incoming work of or the first sprouts of the the Git compiler or a possible Git compiler for CPython. That was very exciting to hear, and like it was a small demo and a technical talk by Brand Booker. I hope I'm not butchering his name, which also is a joke because the similarities between both words. Sorry, Brand. So that was very excited. I think it's I mean, I don't know. I don't want to be a disservice to everyone that has tried JITs before, for sure. But I think this is it just feels right for CPython in the sense that, as maybe if we have time to discuss it, it doesn't feel too heavy and it fits quite nicely. So I'm very excited about that. And obviously, like I will say the other highlight is the work that I'm doing because, why not? Which is this effort that we started to do a better REPL for CPython, so it doesn't suck when you press up arrow and it just shows you the last line of the for loop and instead of the entire for loop. So those are the highlights for me. So what about you?
Like when it comes to the general sense of what people are working on, definitely copy and patch, which is the approach that Brand took for making the proof of concept of our JIT. Like takes the prize because not only does it look like it's very realistic for us, it also kind of fits my brain in ways that I did not expect that part of the project to be able to, kind of provide a high level explanation that I would be happy with. So that's awesome. I also liked how Yuri Selivanov picked up the issue of running, kind of shared data structures between subinterpreters. And like he's done quite a lot of work on creating an immutable mapping that you will be able to use between subinterpreters without the need of serialization and deserialization, making it very quick. So I kind of took part in that like for a little bit. Spend most of my time working with Marietta on making Bedivere and Miss Islington better. Now both of them are GitHub apps. Bedivere is raising fewer exceptions than it was before that week. And Miss Islington became a GitHub app. So I'm very happy to see that happen. And myself, like, I very often am tasked with reviewing code on the repo, and some of the changes that we get are pretty sweeping. There would be refactors or whatnot. So I would want to have some more reassurance that before and after of a refactor is actually still doing the same thing. Like ideally, for example, when we're touching a lot of tests, I would want to know that we still have the same coverage. So I did some work on actually making coverage work now when we're working with regression tests on multi-processing runners, and more importantly, to be able to have detailed and like trustworthy numbers for line coverage of standard libraries, which is a harder problem than you would maybe think in the first place.
Right, we discussed this, and naively one could think like, why are we not using coverage.py, right? Like, why we need this entire new revamp of how we do coverage in CPython, right? And turns out it's not easy at all, right?
Yeah, well, the fun thing about this is that coverage.py itself is using the Python standard library. So by the time you're getting to turn on the coverage gathering, you already imported quite a few libraries, and this code will not be properly reported as being covered, even though it's obviously kind of imported is obviously there. But even funnier, by the time you import site.py during Python startup, like quite a few libraries get imported at the same time, and probably the one that none of our listeners is thinking of is that when you're initializing site packages, you are looking at .pth files.
Those guys.
And those .pth files, yes, like they're not just paths as maybe this extension would suggest. They are actually lines of Python code, and you can put tiny single line snippets of Python there, and they will be executed. And some of those are standard library imports as well. So you really need some way to start gathering coverage information before even that is run. And that is very early in the interpreter startup.
Right. Yeah, if I recall correctly, I mean, maybe we're going too much in the weeds, but I think it's interesting. Like there was some way coverage.py used to work with some hack or something like that with encoding module.
Yes.
You told me, and I was already horrified by the whole problem. But like now, I think I was extremely more horrified about that hack? Like certainly it's not something that people should know about, but maybe we can trace a secret knowledge.
Well, it's no longer super secret, just because NetBachelor actually removed that hack with the latest versions, since Python 3.13 made it harder for that hack to work, which is why now we're going to have proper support for such a use case. But before, Brett Cannon came up with a rather magnificent but also evil, unholy idea where to do anything in Python, to even be able to open files, to access standard output and input, and to even read the user's PY files, what you need to agree on are encodings. So there is a module called encodings that is imported like even before site PY, before anything else, before the open built-in is added to built-ins. The reason why you do this is that you not need to know that, if there's a file using one encoding or another, we are able to decode it and interpret it in the correct way. So Brett's hack was injecting a fake encodings module that actually started gathering coverage first and then found the actual encodings module and only then initialized it after we were already gathering coverage. So that was brilliant. For the official support that I added at the sprint, I didn't go that far, since if we had the ability to kind of insert code at this stage, it wouldn't be able to output anything by print. You wouldn't be able to see anything happening from your hook. So this is maybe, a little earlier than what I set up, but I think it will be harder for people to debug. Like, you remember, you cannot use the breakpoint built in either at that stage. You cannot use PDB.
Yeah, it's also the first thing that breaks when you change the interpreter and you break something like the parser or something like that. It's
exactly right.
Module.
All right, yeah, but like you're probably right that like this is a tiny feature that is mostly visible for us internally. We're maybe spending too much time on this, but the REPL is different. Everybody is going to touch it at some point in their usage of Python. So tell me how the new REPL is different from what we have in Python 3.12.
Actually, it's an interesting thing. Actually, one of the things I was, I work mostly these days on the parser and the tokenizer. When like if someone is using Python 3.12, all the new F strings and all that comes from this work. So one of the most horrifying things that I had to understand there is that the REPL, which is when you type Python and you started to write Python code interactively, the REPL is the tokenizer. As you know, it's like that is a interesting realization, because like people normally the way this is done is that there is a separate piece like that handles all this input and tries to compile the code, but turns out that no, like all this logic happens in the tokenizer when Python is asking for new source. Like you type something and then the tokenizer says, oh, give me something more. So it's quite hard to add any features, because it's literally on a piece that is super critical, is in the critical path. This is the worst C code that you could write, in the sense that it's not bad code obviously, but the problem is that it's code that is written in C that parses strings by hand, which is the most dangerous C code that you can write, because it's very easy to screw up, right?
Wow.
Obviously the code is belly battle tested. I think to this day is the oldest piece of CPython that we have. I think it's 30-year-old. So it's the kind of code that works because it has survived over the years, but you touch something and then something breaks 6 kilometers away. So something that we are trying to do right now is that we're trying to say, well, this has worked for 30 years, but it's the year 2023, and now we have new requirements for REPLs. For instance, right now, if you type a for loop or a function or something like that, and then you make a typo, and then you want to just correct this, I think every Python programmer at some point had to this experience when you press up arrow, and then instead of getting the entire for loop, you get just the last line, and then you need to press up arrow in the opposite way, right? So right. You need to kind of write it backwards. And it's yes. Quite annoying.
Very annoying.
Yeah, and then you make another mistake, and then you need to start from the start, because obviously that's easy. That typing it again, right? So that is not great. And then there is so many other features that are missing. For instance, many people they suffer this, but they don't think about it because they cannot accept it as how it is. One of the things that happen is that if you have a function that you type in a REPL, so you define your function, and then there is an exception in that function, you don't see the source in the traceback. So the traceback says, function foo, but it doesn't show you the source of function foo, because
Yes.
when you type something in the REPL, we throw away the source. Like, it's gone. Like, it never existed. So there is no way we can show it to you because it's not in a file. It was in memory and now it's gone. So we kind of say that it's time to modernize all of this. And I started all this like super annoying and boring work to slowly pull out the REPL from the tokenizer, which is it needs a lot of pre-work. But hopefully the stage where I want to get into is that at some point the REPL is written in Python. So we have some module called the secret REPL or something. I don't know. And then all the logic to read the input from the user and try to compile it lives there, and then everyone can start adding stuff because it's just Python now. And you want multi-line editing, well, you can do it in Python instead of writing 1,000 lines of C code, which is like obviously very complicated. And then you can use the readline module. You can use anything in the standard library instead of having to handwrite C code that deals with this and using the C readline and all that stuff. So obviously we are not going to be as feature complete as IPython or all those other REPLs that are fantastic already. We just want that the default experience is better, right? Like, and as many people told me, like I was chatting with Brett Cannon about this, that is working on the VS Code team at Microsoft. A huge amount of people are just using bare Python, like not even IPython or Jupyter, like just bare Python.
Yes.
And now Python is the language that people use to learn in many countries, like in France, for instance, is the official language when people learn programming in high school. So it's very good. It's a good experience that is going to impact a lot of people. And now the sky is the limit, because once this is in Python, I expect at least that a lot of people will start to contribute. Still, big plan. In the sprint, we managed to do a lot of the pre-work, but we managed to get a feature now. So in Python 3.13, you will be able to see source in the REPL with all the bells and whistles. So all the squiggles that you got in Python 3.11. All the multi-exception, like the exception groups trees and all that stuff. So all of that thing will be available for you in the REPL, which is already a big win if you are writing a lot of functions there or using Jupyter or something like that.
So just to clarify, what that means is when you are defining a function inside the REPL, right? Just saying def name of a function, and there's a body of multiple lines.
Yes.
Right, and there's a call there, and so on and so on. Now we're going to see the actual kind of traceback that shows you the multiple steps of the code that you went through, instead of just a single line in the REPL. That was the last one that we executed.
Exactly, yes. It's the source. Like the traceback already shows the name of the function on the line.
Yes.
So it shows you line 4, but like in a source that is gone because the REPL source is not safe. Obviously, just to clarify as well, if the exception is traveling through existing files, so for instance, if the exception is raised inside the standard library, the files in the standard library will have source because there are files on disk and we can show it to you. But like anything that you type into the REPL will not be included right now. And what we're talking about now is that will not be special anymore. So if you type a function foo in the REPL, we will show the source for that. So it's not like groundbreaking, but it's just a first step to normalize the REPL, and it's not this external
It's making
thing.
it less special, which I think is important, like for just kind of less confusion by everybody, right? Like I can work with the REPL and understand its limitations, but like the fewer of those there are, like the better, obviously. So this is gonna be a big win. I'm very happy to hear this.
Right, and just one last thing. One thing that there was some talk recently about precisely this fact. We will be able to special case some things in the REPL that are not in normal, let's say, Python mode. For instance, a lot of people were complaining that if you type exit, but you don't call it, so just the word exit in the REPL, it will tell you, to exit the Python interpreter, you don't need to say exit, you need to call exit because it's a function, right? And many people will say, well, I mean, if you are able to detect that case, you know that the user wants to exit, so why you don't exit? And the reason we don't do that is because it's kind of a hack. Like that message is the string representation, the REPR, not the REPL,
Yes.
the REPR of an object called exiter that we inject in there. It's all like dark secrets here. But we cannot do it because otherwise we will affect the language. We will need to make exit a keyword. It's just very nasty. And the reason is because you cannot change the token. Like you need to change everything right now. And once we have this in Python, we can special case all of these things. So we can finally exit if you type exit and distinguish that from a variable that you say exit equal 5, and now we don't exit anymore because it's now a variable. So that will be again not groundbreaking, but a lot of it's just the small things that will add up and will give everyone a nicer experience than just super bare bones reading code, right?
So yeah, the fewer special cases like this, the better. In fact, like because of this, I very early on just learned to do Control Z on Windows, since like my initial experience with Python was on Windows XP, and later switched to Control D on the grown-up operating systems.
Right.
So yeah, I still use that to this day. Yeah, but typing exit would definitely be more user-friendly.
Right. Do you want to? I think one of the features most people will be excited about is this JIT work. Maybe we can talk about what we think. Probably we can dedicate an entire episode to this and maybe invite the authors of the work to go more into details. But I think it's interesting to at least give us like first impressions.
The shortest way to do it for me would be to go and actually spend a little time explaining that we had to have quite a bit of a preparation for this kind of JIT to make sense for CPython, and we're already there, right? So we have the specializing interpreter currently, like in Python 3.11 and better in 3.12, which means that certain operations, when we know the types of the operations, we are switching the opcodes used by Python to other opcodes that are the same, but limited on, say, the types that are used on, I don't know, the both operand side, which means we can kind of forego some of the error checking that would be otherwise necessary, because we already know that, for example, we are adding two ints together.
Right.
So now, using that fact that we already have specialization and we have those opcodes that are now using operations that are more efficient, what we can do is we can string together pieces of machine code to create longer traces of code that is fully machine code. And now, a lot of the JITs that we have in the industry make this machine code just at the time, like at runtime, which is where this just-in-time compilation name originally comes from. There are many complications with this, because you need to ship this entire compiler toolchain that is able to do this at runtime. So the copy and patch approach does like something that sounds a little bit like a hack, but I personally find it extremely elegant. So what it does is we have a pre-produced set of small C programs that are compiled with Clang to machine code, which in the end is just an array of bytes. And we know that, this particular piece is this addition where both operands are integers, or so on and so on. But the cool thing about those pieces of machine code is that they are tail call friendly. In fact, in Clang, there is a must tail pragma that you can specify to your code that produces this sort of thing that you can simply kind of tie together. You can combine a bunch of those fragments into a longer trace. So this is the kind of core idea of why we can have a JIT without having to ship compiler toolchain
with Python
at runtime, which is brilliant. That is amazing. We will have LLVM as our build dependency to create all those trace, arrays, essentially, right? But once you are at runtime, we don't need any of those, and I find this extremely satisfying.
Well, one of the more exciting things about this, I think, is very smart as well, because you are leveraging basically an existing compiler to basically generate the machine code. So you don't need to write, like, for instance, a different JIT backend for Intel and for Mac OS and AR64, 32-bit, 64-bit. That's like explosion of complexity, because normally if your JIT lives inside your program, you need to have all these backends, right? If I recall correctly, you probably know it a bit better. I think PyPy has these backends inside PyPy, right? Like
yes.
in the PyPy JIT. So it needs to explicitly support this. But here, you have as many platforms supported as your compiler does. So we have these C templates that are the different, patches and pieces of code. And then we just call the compiler in the specific platform. If you're in macOS, we use Clang for macOS. If you are in 32 bits, we use Clang in 32-bit mode, and you don't need to write this by hand, which is, and not only that, but now you also have a optimizing compiler for free as well. So those pieces of code are extremely optimized, and you're leveraging all these, years and years of Clang development that otherwise you will need to re-implement in your small JIT, right?
Right. All of this is true, and this is like very promising. But the overarching idea is something that I can kind of grasp, and I can understand. Like, okay, like this is something that grows out of the specializing interpreter, and this is the stage where it happens. You can actually not only look at the kind of cryptic machine code arrays of bytes. You can do that, obviously, but you can look at the source code for what made them, which makes kind of understanding and analyzing what is happening way clearer to kind of my simple brain. So I am very happy that this sort of thing exists. In fact, the first I heard of it was, I think, the originator of the idea, where a new kind of Lua JIT was built with this technique, and it was found not only to be feasible, but also to be close to the performance that you can achieve with handwriting a JIT that creates those machine code traces manually.
Right. I mean, there is also, just to be clear here, there is some complications still that you need to figure out. So for when you load those pieces of compiled code into memory, there is a bunch of addresses that are not known at the time. So for instance, if your JIT compiler calls a Civ API function like by number add, that it doesn't know where the number lives. So there is some piece that we need to still write in Cpython that finds out, okay, we once we compile the final Python code, where this symbol means, right? The technical term is symbol.
Yes.
So it finds out, and then it goes to the machine code and substitutes that. So there is all this filling holes thing, so it's still some work that you need to do, but it's orders of magnitude less than and that's great, because one of the biggest worries that I think we have as a team, with the idea of having a JIT compiler, okay, yes, let's say we have one, and there's some requirements, but who's going to maintain this? Because now you just to touch all of these things and even debug these things, you need to know now assembly and different platforms of assembly, all this stuff. So here you have obviously some complexity, but I really think this is a super smart approach, because it's extremely more maintainable. You get platform support for free. It's optimized already for you, and you don't need to ship the entire LLVM infrastructure, which is super heavy, right, at runtime.
Right.
So your binary is also very small, and I'm very excited about this. Obviously, this is early stages, so we and this, I think this also, I don't think we mentioned it. This builds on something that is this idea of Tier1, Tier2 interpreter. Maybe we can give some small explanation of what's going on here.
Sure. I already mentioned some about how we are transforming opcodes into versions that know the type of the operands and so on and so on. But since you are part of the Faster Python team, you have more context, so maybe I'll defer to you actually.
Okay, so I think we can probably also invite someone who can explain it even better. But the idea here is that right now I think we have the bytecode of Python is very high level bytecode, in the sense that you do this instruction when you say add two numbers, right, or iterate over for loop, or so they feel, obviously in the scope of an entire program, they feel very small, because obviously your program is made up of hundreds and thousands of these, but as an instructions they are, is still very high level. Add two numbers, there is a lot of complexity there, because it can be two integers, or one float and an integer, so it's different things that you need to figure out, and that is in the same instruction. So these instructions are quite big, which means that when you start thinking about trying to translate into machine code, it's a bit harder. One of the reasons is because if you want to now put a bunch of these instructions together, it turns out that they are too generic, that the possible combinations are much harder. So the JIT basically can generalize less. So the idea now is that you have this piece of code that this is tier 1, I think. I don't know if it's 1 and 2. I think it's tier 1, and then the other instructions are tier 2. So the tier 2 instructions is basically the idea of having much simpler things. Like, so not even like for loops, something like that. It's like, add 2 integers, so not 2 numbers, 2 integers, or like, pull number out of list or something like that. So much smaller pieces that maybe don't have an entire operation reflected into the code, but they can be composed together. If in the terms of processors and instruction sets, it's like CISC versus RISC, right? Like
Yes.
like ARM instructions are much simpler. You need many more, but on the other hand, you can combine them in many other ways because they don't do much. So every instruction is very small, very fast, very efficient. While Intel instructions, for instance, like CISC instructions, are big chunks of things. Like for instance, move can do like plenty of things. Like I don't know, like you have seen the paper, but the move instruction is actually Turing complete. Like you can have an entire program that is just moves, and someone actually made a compiler called the Mobfuscator that transforms any program into just moves. It's quite cool. Like they have this talk when he does like this, counting back from 100, and the whole talk is this program counting from 100 to 0 in the background because it's obviously very slow.
It's slow, and the branch predictor also doesn't like it, right?
Yes, and also there is this image on like these decompilation programs that show you the control flow, and it shows you like oh, look at this like for loop with an if condition, and it's like all the arrows, and then it's like after the obfuscator it's a single line of moves one after the other. But the idea is that once you have this tier 2, which obviously it takes some time to translate the first instruction into the second instructions, and then you need to like do some tracing as well, which is like you need to see what the code is doing, and we are adding integers, and we know that they are integers, and you need to do a bunch of other things like abstract evaluation to know exactly these pieces are doing this thing, and like we can eliminate this code over here, and a bunch of things. But once you have the simpler instructions, you can now activate the JIT over those simpler instructions because they are more composable. It's more easy to just say, let's compile every individual one and then start merging them. And this means that you just need to compile you need just templates for the simpler instructions instead of one template that is enormous for every of the complicated ones that are harder to compose. Obviously, there is a lot of nuance here, but this is the basic idea.
Sure. So one of the things I liked about this, because like the listener can have a question like cool. So if we are adding 2 integers together, that might be true now, but maybe the next argument that comes to the invocation of this function, to the call to this function, is going to be a float or maybe something entirely different. You can use user classes as well with the plus operator. So what's going to happen then? So what we have is like kind of cheap instructions that are called guards, where we check that the arguments are still true for this particular combination of chosen types. And now with the JIT, we can just take all those guards and put them in the front of an entirely long trace and do this check once instead of, like inside for loops iteration, where we know this should be true for the entire duration of the for loop, making it way faster than what we can achieve right now, because the fastest code that is running is the one that you actually avoid executing. So like this looks like a very promising approach for us.
Right. And I think I'm very excited. Like there is a lot of like excellent engineering going into this. So and I'm very excited to see how far we get. But I think this is the first time I'm pretty confident that it's very likely that we end with something that we can actually ship, and it's not extremely heavy, without being obviously disrespectful to previous attempts. But there is this internal joke that JITs, there is this graveyard of JIT compilers attempts. I think Mark Shannon actually have a repo called JIT Graveyard, and like he registers all the attempts. So hopefully we don't end with an extra item there.
Well, yeah, hopefully. Like we didn't only have Brandt's talk about the possible, kind of ways forward from the specializing interpreter as implemented in Python 3.12. We also had Kenjin talk about how we can further make those tier 2 bytecodes performant. Can you talk a little about how like what you think about that and how that works?
Well, he has been. I think this is based on some research that he's doing in his university with some colleagues there and a professor there, and they have been trying. Like he's been working really good and hard, like trying different approaches as well. So once you have, and I think he said that he had already like a copy and patch version of this, like he did. Like it's quite cool, independently of brand, right? Like some kind of maybe simpler or something like that. But he's been playing with different ways to, once you have those simpler tier 2 instructions, you can now try to, before you pass them to the JIT compiler, you can now try to analyze them in different ways and start to simplify things. So for instance, once you, and the good idea of like having the simpler instructions is that running different kind of analysis over all of them is much simpler, because you have like more visibility over every single piece of code. Because if you merge all those big ones, like, for this, for that, like it's harder to see how the different values are flowing through the different instructions. As you said, I mean, it's maybe not the best example, but as you say before, you have like the iterating instruction for the for loop separated for the addition of the integers. The addition of the integer instruction is to constantly check, I'm still an integer, even if the for loop knows that obviously it's not changing the integer. But once you have these small ones, you can start tracing values through the whole thing. So you can do a lot of cool things like, escape analysis and like remove redundant pushes and pops from the stack and things like that. And he has been working on like different ways. So he's, if I understand correctly, he also is trying like very bare-bone different approaches as well from the one that the faster Cpython team is immediately implementing, which is right, because like we are charting kind of like different ways we can start moving and what are more promising. But the idea is that he had like a good structure, and he actually mentioned that he built the first version of a copy and patch in 2 days or something like that, if I recall correctly, which is quite amazing. So yes, like the idea is that he's working on ways to analyze all of these instructions, if I remember correctly. And once you have all of the instructions together, you can start doing some kind of like, static analysis. And he's pulling from a lot of compile functional languages. So for instance, one of the things he was looking at is that this idea of pure functions. So a pure function is a function that only depends on the input, and the output is it doesn't change basically the state. It doesn't have global state or side effects. So it doesn't, the jargon in the functional language is that it doesn't throw nuclear missiles, right? Like so if I call your function with 2 arguments, it's not going to do something sneaky, right? Like it's not going to insert into a database, or it's not going to set a global, or in this case throw missiles, right?
Yeah. So there's no action at a distance.
Exactly. It's like a mathematical function. I give you 2 integers, you give me 1 integer back, and that's it. That's the whole idea. And the good thing about this function is that you can predictably optimize it away and do certain things, because you're not scared that, if I remove this call, something weird is going to happen. I think everyone has this feeling when you are like refactoring a code base, and then you find this function and it's like, this function is not doing anything, so let's remove it, and suddenly everything breaks because the function was secretly changing the configuration or something like that, right? And it's the same idea, but in the world of compilers, you have a pure function. You have something that that it's not doing anything funky, so you can maybe inline it, for example, or you can like optimize it away and substitute the final value. For instance, this is something that Clang is doing for some very special cases. So if you are adding all the numbers between 1 and n, instead of like calculating it, there is a closed formula for the result. So you can say, well, where am I going to calculate if I know the result is this, and I just substitute the formula. Well, you cannot do that if your function, apart from calculating all these numbers, it puts them in a database, right? Because then if you substitute for the result, it's not going to put every individual number in the database. But did you know that it's just giving you the result, so that you can substitute the entire function for the result, and that's it. Or you can cache it, for instance. This is, but it's surprisingly the amount of functions that you will think they are pure and they are not. For instance, would you think that let's say the cosine function in libc is pure? It's a cosine function.
I would assume it should be, yes.
it's not like you can actually mark them. There is this attribute pure. You can tell the compiler, oh, I have this function is pure. And the reason is because there is some global state that the function has regarding the floating point, arithmetic stuff. So it sets some cache as well. So if you call the function for a bunch of the same argument, it gives you the same argument without calculating it. And there is some approximation. So there is a lot of things that they are not technically pure. But the idea is that once that the Python function is pure, a bunch of code, maybe not the entire function, but a bunch of code is pure, you're gonna start like thinking about it and maybe move it around and optimize it. So you think like this, and he's pulling a lot from these functional languages that have these concepts very well defined, and trying to find ways to, let's say, have a more like higher quality tier 2 like set of instructions before feeding this to the JIT compiler. So the JIT compiler has even less thing to do.
Right, because a lot of Python usage is surprisingly predictable and static. It is a dynamic language, and the operands can change widely, obviously, but very often, like, they are generally known to have like certain types. Like, a lot of the for loops are around a range, right? And in this case, we can very clearly tell what the operands are going to be, and so on and so on. So like, this looks like a very promising way to make the JIT do less, which is going to be faster, right?
Right. I remember someone describing what you just said as the funkiness is very concentrated. So, like most of the stuff is just normal. And then there's this weird code that monkey patches some weird stuff, but it's just this super specific path. And that's the thing that's going to give you the headaches, right? Like that's the pain is there. But most of the code, as you say, is like very regular. And if you are adding integers now, you probably will add integers later. So there's not going to be super generic code.
Right. So
most of the time.
So if you want to follow how this is shaping up, instead of just looking at our repository, which you can, and you can build your own Python, you can also grab our periodic builds of Python 3.13, where at the sprint we actually did the first one. So 3.13 Alpha 1 was released on Friday, on the sprint Friday, just to possibly attract some of the core devs into volunteering to be the next release manager for Python. Now we have Thomas Wouters being the 3.12 and 3.13 release manager, but this is a rolling position, and for the 3.15 version, we're going to need a new person. So we were demonstrating how our release works and how we're making the particular steps now greatly simplified by Pablo's automation, but still requiring some manual editing, like, I don't know, like the release notes and building the installers, which like, thanks to Steve Dower's efforts for Windows, only requires us to click a nice blue button to start the pipeline.
Two of them actually, right? Like, there's 2 buttons.
Well, there is many buttons, in fact, if you want to like go into details, because it is not only automated but highly secure. So it's a pipeline that is public on Azure, so you can watch it once, while it's running without logging in. And what you're going to notice is that there are many steps in it, and sometimes some of those steps ask the original runner or another owner of the pipeline. The pipeline asks for the step to be approved, and the reason why is that this particular step to be approved is unlocking some sort of secret. For example, it might be like the certificate with we're signing the release, or an SSH key with which we are logging into our download server to put the files there, and so on and so on. So there are a few approval steps for the blue button, but the initial pipeline is as simple as specifying what we are actually building and clicking run.
Well, one big thing that we are discussing these days is precisely the security of the release process, right? Because, for instance, as you say, there is a lot of automated steps, but like, they happen on the machine of the release manager, right? So you kind of like, what is happening there, right? What if you have a secretly evil release manager that is publishing some weird new module, called git.py that has, or REPL.py, right? That has all the secrets. So, and we have now a security developer in residence. We have many developer in residence in this podcast. But we have a security developer in residence that is actually looking at this right now. Maybe you can comment something
Yeah,
about this.
right. So, like the umbrella of those updates, in fact, is to make our releases reproducible. So, in the kind of ideal world, you should be, you should be able to reproduce a release to the bytes, like, so like it should be the same tar xz that I produced. I should be able to produce exactly the same one the next day if I am starting from the same sources. So this part is in fact already there for us. Like Seth Larson, who is the security developer in residence, updated our release script that builds the source releases in a way that removes a lot of the variability from the tarballs and from, kind of file ownership and dates that are in the produced files and so on and so on. So the expectation is that as long as you are working with the same tooling, with the same libraries on the same operating system, you should be able to reproduce the exact same tarball more than once. And I attempted this and arrived at the very same tar exit file with the same SHA-1 sum as Seth did. So yeah, like success. We are already there. And now the kind of step further from that would be to make the rest of our releases, which are the binary installers for Windows and macOS, also kind of depend on some of that, right? So if
Right.
all of those steps will be kind of made at some point, they can be automated so that we can except for the approval steps, essentially make the entire release outside of the release manager's computer, which obviously is better. I don't think we really need to worry about trusting the release manager, but we definitely should be suspicious of any computing environment that even a careful release manager is running, their releases with. So, kind of malware exists. There can be, some dependencies that you're pulling that are not the ones you want. There can be, I don't know, like tools on your operating system that don't exactly work as you'd like. So far, we haven't really seen malicious use of this, but we've been plenty annoyed by differences between, say, auto tools, right? So autoconf would have different output depending on the operating system, even if the version is the same. Now we
Which is
arrived.
bananas. Like I
Yes.
still flabbergasted by this. It's just ridiculous.
Yeah, so we now arrived at a version that appears to be okay, but even then, we settled on running a container for this particular piece because that
It's
is the
just
only
ridiculous.
way to make sure.
It's just ridiculous, man. Like I think it's like this is the reason people take quite a lot of time to move to new versions of Python, because like it's the same it's the same feeling. Like if they are already like scared to move, different versions of Python, just they should try different versions of auto tools, which is just like Jesus Christ. Like I mean this thing. But yeah, I'm quite excited about that work as well, because it's quite important, and we are, depending on how you measure the second or the first most popular language. We are also the target of like a lot of all of these malicious intent. Like if you look at the status of PyPI malware, it went from 5 malicious packages, I think 6 years ago, to thousands, like even a month, to the point
Right.
that we had to stop the entire PyPI upload and this year for a day or something like that, because there was so much malware being pushed that we had to stop it. So this is a real concern, and even more, like there is even governmental bodies that are pushing a lot for this audit. So it's maybe not flashy work, but it's very important. So we are very happy
Oh,
that it's
it is
happening.
extremely important. Like one nice part of it, for example, is that like now we are signing our releases in a new way that is also reproducible and also like kind of more easily verifiable by external parties, like which is called Sixstore. Like the rollout of this was essentially also the finalization of what Sigstore is. We were a very early adopter of it, but by now, this is a very cool kind of way of making sure that the releases that you're downloading from python.org are the ones that we published and we claim we published. Since, kind of there is a third party that stores the fact that, a package was signed, and you can verify not only the hash of a file, but also the fact that, okay, it was signed, and it was signed by the person who said it was signed with, and it was signed using some, OAuth, provider that we, or more correctly, OIDC provider that the file says it was signed with. So I, for example, use the github.com provider. The other release managers would use Google for this, and it is a much more transparent and secure way to do this than simple GPG keys, which we still kind of use because we didn't really phase them out. But as we know, and if you don't know, you should look this up, like the web of trust has been broken. So
even the more important fact, I will say, more people will probably find this closer to you don't need 6 PhDs to know how to sign the thing and validate it. Because it's just crazy. Like the actual command that you use with Sigstore is Sigstore verify, and that's it. Like it used to be even Sigstore verify 2 files or 3 files, that you need to download. I think now is smart enough to find them on disk and whatnot. So it makes sense, and it will tell you good and bad, and like not like this weird output that you will say like armor or like it's like doing transformers when you sign these things. But now it's more sane, and you don't need like weird things just to sign it. Like I used to sign it with the YubiKey, and like it broke, and like now what do I do, right? It was good I have a backup, but signing with like these providers is not only more transparent, but it's also easier to audit, and it doesn't depend on like arcane software that the only way to work with them is like finding some 90s forum or blog post that explains the sequence of 30 commands that you need to write to do it.
Yeah, that was work that started before we got the security developer in residence. But once Seth started working with us, like this became way smoother for us, and I'm very happy to work with them. Since the changes that he is bringing, like, are actually making the Python kind of release process not only secure, which I don't think we were particularly insecure in the past, but really kind of the state of the art secure.
Right.
Compared to many of the other programming languages that are in use.
Right. And I think that's quite a good description of the sprint as well. I think we are missing probably a lot of details. There was obviously one of the, just to mention it so people don't accuse us to, like forgetting about it on purpose. There was a lot of talk about like the CAPI. That's a big item these days.
Yeah, the CAPI, as used by our users, is like a way for like external code written in the C programming language to interact with the C interpreter. And historically, we didn't have a good notion of what is an implementation detail and what is actually meant for external use. This was like improved over the years. So by now we have a pretty good idea. But not only do older extensions kind of, still use the old ways of doing things, but some extensions kind of consciously decide to use implementation details of Cpython to produce code that is, for example, more efficient, or to allow a thing that is impossible to do otherwise. And this is making our lives harder because updating those internal APIs is breaking those C extensions. So there is a large problem space there. And in fact, I don't even have to make a summary of it because now we do have a PEP that is a summary of the issues with the C API.
Oh, this is the one that Edith made, right?
Exactly right.
And this was like, this is a ginormous topic that is full of like areas and alleys and things like that, because not only like defining the problems, but it's also defining, like all possible attempts. And like there was all this talk from the HPI people that are already thinking very hard about these problems and working on a way that also allows other Python implementations to work. So you don't need to, compile an extension with, or prepare your code with 6 million if defs just because you want to support PyPy and CPython and things like that. So there is like this topic is huge. Maybe we can even do an episode about this in the future with people that are closer to the trenches that we are, right?
Right. Okay. So what I'm seeing here is that we have PEP 731, which is the charter of the CAPI working group, as just founded, I guess. And it does link to a group of problems, like an inventory of problems with the CAPI. And so if you're curious, you can go and look there. But yeah, definitely it's good to see large interest in addressing this. Obviously, kind of possible futures for CPython dictates also necessary changes to the CAPIs, which is why this particular problem space is seeing, kind of a lot of interest right now. Because when you remove the GIL, or when you have sub-interpreters, or kind of if you're doing the JIT, like suddenly different sets of APIs are going to be needed for this, and how those different modes of operations are going to interact is an entirely new area of research. Like we are now no longer copying what Donald Knuth taught us. Like we are now actually kind of looking for the next book in his series, because this is science that hasn't been done yet.
Right, and it's quite hard because there is a lot of things happening at the same time that all touch the same core, right? Like as you
Right.
mentioned, removing the GIL not only requires thinking about how you're going to be compatible with the previous extensions, or if you're not going to be compatible, what you need to remove or add, but also you need to think about like what do you need in the future that is general enough that you don't need to keep changing it, but at the same time you have multiple interpreters happening. Like if I recall correctly, like even Yuri Selivanov was talking about needing new CAPIs for his memhive
Right.
thing. So it's very core, and like as we add more things to this, or even deprecate, it has a lot of ripples through the entire ecosystem. NumPy doesn't work, right? And why is not? Because we changed this thing, and because Python changed this other thing. So it's core to the experience that a lot of people have when porting to new versions. So getting it right is fundamental, and the problem space is quite big. So yes, there was a lot of discussions around CPI in the sprint. So it's very difficult to summarize the whole state. I think at the point is they were just mainly collecting the problems, right? So it's not like we didn't arrive to any solution or any area to work on, right?
Well, there were a few presentations from different kind of, I don't know, experts or interest groups, as you might call them. A veteran of the Python project and a very prolific core contributor, Victor Stinner, gave a summary of the problems as he is seeing them, and there were some suggestions on how we address them in the future. And Petr Viktorin, who is working very closely with the CAPI as being a Fedora maintainer and somebody who is, advocating for stability in this regard, like had his own perspective on this. And finally, we had the HBI guests on the sprint, teach us about the kind of experiences they had with introducing a new kind of API for Python, and things that we will definitely need when we're thinking of a future version of it.
Right. Yeah, and there is a lot of exciting things there. Like the whole HPI is super easy to debug. So yeah, like certainly that made me quite hopeful. Just all the hours that are being spent debugging reference counting, and they have a thing that can just point you to where the problem is, right? So, but yeah, maybe sometime until we can use something like that.
It won't tell you where you should be putting your decref, but they will definitely tell you where the extra ingref is. Yes.
Right. Yeah, very excited about all of work, and it's a lot of very good technical work there. But cool. I don't think we are leaving. Well, I'm sure we are forgetting some things, but I think that's a good summary. Do you want to add something on your impressions, like maybe a summary of the experience for this year for you?
For me specifically, working from Poland and kind of being both different time zone than the other core contributors, but also very much a different physical space, meeting with the team is always like a family reunion. This is a special time of the year. I value it very highly. Brno was a place that I haven't, visited before, so I was very kind of surprised at how kind of friendly and interesting the city is. Like there's some quirky art here and there. Like kind of the buildings look very impressive. The downtown, especially the historic downtown, was an established living city, and it was just very pleasant to spend evenings there after we spent the entire day at the Red Hat campus. So I enjoyed it quite a lot. It's gonna be hard for us to kind of meet that bar with some of the American sprint weeks where you can walk for hours to get absolutely nowhere.
Right.
You absolutely need to take Ubers and so on and so on, where the tragedy of the public transit is that there is no public transit. So we'll see.
Yeah, still, I mean, if I enjoy quite a lot the sprint that we did in San Francisco, I remember the transport situation was something else. So certainly, I shared your comments about like how cool it was just to walk and like meet people. I remember like at some point, we were for after dinner we were looking for Victor. Like we didn't knew where he was or he didn't know where we were, and like we were like 4 streets away, right? And like
Yes.
that is impossible to replicate in our American city. You will need 2 Ubers and like three hours of walking just to meet if you don't know where you are. So yes, like that was nice, and it felt calmer, right? It was chiller, right? Like more chill
Yes.
than maybe other
Well,
sprints.
I do have to mention the irony of the situation where I did bring a car to the sprint. So I'm talking about the public transit, and I'm the one that didn't actually take it. Yeah. I get all
It will
this.
not be who complains because you pick me up in the airport in Prague from Brno, which is 2 hours driving one way and then 2 hours of riding the other way at like 2 a.m. or something. So I'm not going. I'm not the one going to complain about your car.
Yeah, I mean, like I was the kind of ad hoc taxi driver for a few people, which is nice. I do enjoy my road trip, so don't get me wrong, Americans. Like essentially, I'm not against like a good experience on the road, but if this is your only option, that makes things more complicated. Like in Brno, we had both the ability to kind of choose where we want to go with the car, but most of the time it was very walkable. So once you reach downtown, you didn't have to worry about parking. You didn't have to worry about like, kind of having a beer or two because we were already, where we needed to be. So that was definitely fun. What else was there? We had a steering council Q&A at some point, and you are on the steering council. So anything to add on that?
Yeah, I think it was like one never knows how these Q and A's will go. So I think one interesting aspect that we discussed quite a lot is the idea of improving diversity in the core team, and that's a very interesting topic because we are all aligned over what the goal is, but it's challenging to devise ways to arrive there, and it's something that we know that there is a lot of things that we still need to work on. Like our diversity numbers don't look really well, although we have improved over the years. So it's not that we are sitting still, but we still need to do better. And there is a lot of challenges. I think there is also a lot of things to try. I think Carol Williams was mentioning the idea of like setting up some link between core developers and PyLadies, so
Right.
to start mentoring. And we discussed several aspects of our workflow and culture that could be improved to allow more contributors. And also some challenges, like I mentioned, like for instance, that I've been mentoring 3 women this year in the project, but unfortunately, we they didn't decide to continue, which is fine, right? It's not you're not forced to continue to be a core developer. You can just contribute, and that's fine. But unfortunately, one of the reasons they didn't want to continue was because some of the interactions with outside contributors were not super nice. which is not like, like, to be clear, the code of conduct was not violating this interaction. It's just that, it's a difficult space to be, because people are very excited about their project being working, and we do changes that they think that we shouldn't do, but we did it anyway because we need to move the project forward, and they are a bit vocal about this. So nothing fundamentally wrong, but this impacts a lot the experience for a lot of contributors. So we had some discussions about like how we could improve this, and like what the problems are, and maybe some ways to the ways different core developers see mentoring. Mentoring was a big aspect that we discussed quite a lot. Like, how do you approach mentees from different backgrounds, different needs? How do you one of the problems that many people have when they contribute to the project is like, how do I find an easy issue to start with, right? And like how that is like the hardest part, because like the Python project is a super old project, and there is no more low hanging fruit. So there is no such thing as an easy issue. I mean, if it is, it's probably behind the eternal discussions of like 10 people discussing different ways to do it. So it's not just a matter of like someone needs to code this, but it's just a matter of like someone needs to combine everyone.
So sometimes something that is easy in code is going to be hard in reaching consensus, and other times something that is seemingly easy, like only you will discover it's a can of worms once you get closer to it and open it.
Right. And I think the other thing that we discussed in the Q&A was the notes from the steering council, that they tend to be a bit vague and like maybe late. But we discussed, I mean, again, I don't want to be apologetic for the steering council on the notes, but like we discussed one of the reasons this is like this. Like one of the things that happen is that those notes need to be taken by the steering council itself. So one of us rotates every single meeting, and the notes have different styles, and then we need to review them. So there is a long process that is very difficult to streamline, although that doesn't mean that we need to improve it. But that explains why they tend to be a bit late. And also, like, there is a lot of details that normally are kept like vague, because like we cannot talk about the individual comments that everyone in the steering council made. But we need to speak with one voice, which is what the PEP says. And that means that, we cannot just explain all the thought process that we have, because we are obviously not like a hive mind that we sit together and vibrate and we produce a decision. We speak individually, and that those things cannot be placed. But we highlight some of the problems that this still have, like the feeling that someone submits a PEP and then it's like nothing for 3 months, and then it gets a decision, and that sucks, right? Like, in the sense that this is maybe not a good feeling. You may need to keep revising your thing. So we understand this. We are aware, and we discuss several things that we can do to improve. For instance, one of the things that we have, which is open to everyone, is that the steering council is offering now office hours. So 1 hour before our meeting on Mondays. So this is, our meeting starts at 6:30 London time, which is the time. And now I'm not going to say any other time because I'm really bad at time zones. So you convert it in using Google. So at 5:30 London time, you can actually request it's half an hour, so it has to be at 6. Well, anyway, it is there somewhere. So around 6, I think, London time, you can request like a meeting with the steering council to talk about whatever you want. I mean, this is obviously is going to be leveraged mainly by core devs, but I think it's open to everyone. So you can like bring your concerns. So if you are proposing a PEP, for instance, and you have not heard from us in a long time, and you want to share, or know a bit better about the situation, or you want to share some nuance that is around these things, or you want to know, how some decisions the steering council took and things like that, you can request this time, and then you can have a meeting with the steering council. Anything is a good topic. We expect that many of these like edges that are maybe not the best are a bit easier to people using these meetings when they can share information with us and ask us questions, and they can have a more direct line of communication. Obviously, there is also other ways, so you can open still issues on GitHub, and there is many ways to contact the steering council. You can send us an email, our email address. But this is like obviously a more direct way. So hopefully we can address some of the concern that core developer had regarding communication with the steering council, and not seeing the steering council as this entity that is there and makes decisions, but it's impossible to understand how they happen, right?
All right. Very cool. So if you're listening to this and you're like, hey, I've been at the sprint and I was working very hard on this one thing and you didn't even mention it with one word, then let us know. We can talk about it like next time, and we can put some more focus on more of those kind of contributions that were made during the week in Brno or after. Like the only thing that we need to be mindful of now is that we're already past the hour mark for this episode, so we
But
need
with the
to be
magic of
mindful of
editing, it
time.
may be even shorter, right?
Oh yeah, we're gonna just cut out all the things that I bored you with, so it's gonna be 15 minutes. It's gonna be a 15-minute long episode.
Right. This is not an official Cpython product, yada, right?
Yeah. This the
Don't
recording
sue us.
process is not reproducible. Like we can
Right.
do post edits that are very deep.
Right. Cool. I mean, I'm very excited to see what the listeners think about this, if they find it interesting, or like what aspects they think we should talk more or maybe less. If I should change my Spanish accent to something to something better. But yeah, please reach to us. Probably I don't know, like Twitter for me, or email I think works as well, to
Right.
tell us what you think. And we can probably improve it in new episodes.
It's not Twitter anymore. It's X Twitter. It is no
And
more.
it's always X, and then between parentheses, formerly Twitter.
Okay, so thanks for listening. This was the introductory episode of core.py. We hope to make more of them. How often? That is still to be decided. Like we are targeting to do, once every 2 weeks. I'm trying to avoid the bi-weekly word, which is kind of hilariously ambiguous. We can say fortnightly, but that sounds a little Shakespearean to me. I don't know.
It's cool, man. Like once I learned that word, I'm using it everywhere. It's like fortnightly.
Yeah, sounds like you're Romeo. It's like, oh yeah, fortnight.
I'm not trying to seduce you, Łukasz.
Right. Cool. Let us know how this went, and if you'd like us to change anything. Yeah, this was fun. See you next time.
See you next time. Bye.